Hi everyone, in this video we're going to look at the second lesson in the particles and energy scheme, which I tend to have called atoms and energy, but really this lesson could be called matter and motion. And the reason for calling it that is because this is, I guess, an introduction to physics, which in the classical sense at least, which students will be studying at school before they get to the whole crazy quantum world that they'll look at university. But in the classical sense, physics is all about matter and motion. That's to gloss it a little bit, but this serves as an introduction to that, which is a big part of physics. And really, what this lesson, how this fits into the curriculum, is that it builds on the previous lesson, which was an introduction to science in general, and it gave students this guess, deduce, check model through the mystery boxes activity. What this lesson serves to do is to give an example of that, which is this really fundamental idea that pretty much everything else in science is built on, which is that all of the matter in the universe can be thought of as being made up of these tiny particles. And this idea of breaking things down to constituent parts until they get smaller and smaller and smaller, a bit like the building blocks of life, which we think of as the cell. Well, this is really the idea that underpins everything. So within chemistry, within physics, and within biology as well. So the way I would start this is by contrasting this idea that matter is made up of these tiny particles all zipping around all over the place. Contrast that with the ideas of the ancient Greeks. So we're going to start, and I would always lay this out in the same way as we did in the first lesson with the mystery boxes. We're going to start by thinking about the guess. So what was the guess of the ancient Greeks about how the universe was structured? And what I tell them is a little story about Aristotle and his four elements and how he thought it all worked. And this is super interesting. It's really worth you reading up on this before you go into the lesson. But the idea is the way the ancient Greeks thought about the world and the universe was as follows. So they thought that all of the matter, all of the stuff in the whole world was made up of four elements. And I'm sure we've heard of these before. What you may not be familiar with, which is worth reading up on, is this idea that actually, because they had this geocentric model of the universe where the Earth was at the center, the way they thought the four elements interacted was based on where they were in the kind of hierarchy from the Earth upwards towards the cosmos. So they placed Earth at the center. They imagined water was what surrounded the Earth. Obviously, this isn't to scale, but we've got Earth at the center, water, so the oceans, which kind of sat around that. Then we had this layer of air around that. And I would draw this in my books and get students to draw with me because I want to give them this model. So this was what we would now call the atmosphere, but I don't think the Greeks thought about it in those terms. But they had this sense that there were these airs, the name which was the precursor to gases, that floated around above the Earth's surface. Somewhere in here was the sun. So maybe I'll draw the sun here. This was this great ball of fire. So I'll label that with an F. And then around all of it was thought to be this unchanging cosmos. So I'll label this as the cosmos, like this. And it's not difficult to see why. This was the picture that was presented by Aristotle, by the way. It's not difficult to see why, this picture was adopted by the Christian Church, because the idea that you had the Earth at the center moving out towards this perfect, unchanging, spherical cosmos that surrounded absolutely everything, that fit quite nicely with the Christian teachings about heaven. So this was a really powerful idea, and it was hard to shift, as I'm sure you know, from the time of Aristotle, about 300-400 years before the birth of Christ. It took about 2,000 years before it was widely accepted that this model was completely wrong. And we're going to look at that in a later part of the curriculum because it's really important and really interesting. What we're looking at today, though, is why this didn't really tell us anything particularly useful about matter. So the deduction that could be made from this sort of thing, and what Aristotle's thinking was based on, was the idea that all of the motion of matter in the universe could be understood in terms of where things lay in the hierarchy. So let's imagine a stone like this. And I'll draw this to students and tell them this story. So we've got a stone here. And you could even ask them, what element, in Aristotle's view, do you think a stone is made up of? And hopefully they'd get the idea that a stone like that is mostly made up of earth. Now, Aristotle's idea was everything has this kind of form, this natural place that it wants to arrive at. Well, if a stone is mostly made up of earth, well, wherever it is in this world picture, it's going to want to get back down towards the earth, which is why the stone falls down towards the earth. And I could draw the earth down here like this. So if this is the earth here, so that when the stone lands down on the earth, well, the stone becomes a happy stone. That's where it's supposed to be. It's where it belongs. But there was a great set of discoveries around the time of the scientific revolution. I'm thinking Copernicus, I'm thinking Kepler, I'm thinking Newton. They realized that actually this picture just didn't hold, because what Copernicus realized was that actually the sun was in the middle of this big scheme. So we can draw the sun here like this. And Earth was actually in motion around it. I'm sure I'm not telling you anything new here. This may be new to the students, however. Obviously, we have Venus, which is a little bit closer. We've got Mars, which is a little bit further away. Draw that there. We've got Jupiter out here, and so on. And all of them are moving around the sun at various speeds and so on, different distances away, like this. They're all moving around the sun. And what was realized was that actually they're all made up of exactly the same stuff. And the laws that govern their motion are exactly the same as the laws that govern the motion on Earth. And this completely blew this picture apart, because actually these are all just lumps of rock spinning around throughout the universe. There's nothing particularly special about any of them. They're all made up of the same stuff as our Earth. So this whole picture was proved or thought by the discoveries made by Copernicus and so on, thought to be wrong. I'm going to be careful about using the word proof at this stage, especially with year 7s. But the point is here, we needed a new guess. And the new guess, and I'll use the same layout as we used in the last lesson, the new guess that we had, and that's what we're going to look at, is what this whole unit is based on, is that everything within the universe, and for the universe I'll just substitute the solar system here, but everything within the universe is made up of nothing more complicated than these tiny, tiny little particles called atoms. And what we need students to understand is that, I'm going to add the arrows here like this, is that pretty much everything to be understood about the world can be understood in terms of this matter. So I'll put atoms here, or you could say particles or atoms. I tend to use them kind of interchangeably, although, yeah, we tend to use particles a lot more. So I'll put atoms / particles. But really what we're talking about here is matter. And then we've got all of these particles have this stuff called energy, and we're going to talk about that in the next lesson. So I'm just going to put energy here. But the point is, in this case, that refers to the particles or the matter's motion. And what I really want students to understand by this lesson is, firstly, how we came to this idea that actually we're not going to consider things in terms of where a stone belongs in the universe or where fire belongs in the universe and so on. We're not going to understand it in terms of these final causes. Actually, we're going to understand everything in terms of this really simple picture of matter and motion. And everything that can be explained in the universe, this is a fundamental assumption of science, everything that can be explained in the universe can be understood in terms of this matter, these tiny little particles zipping around, and how much energy they have determines the properties of that matter. So again, this is another of those lessons which might seem tempting to skip, but I think it's really, really important that they see how we came to this idea that matter and motion are the fundamental categories with which to understand the world. And I think it's also really a nice to introduce early the ideas of geocentrism and heliocentrism, Copernicus, and so on, so they get a really clear sense of just how important these discoveries were. Once you've finished teaching this lesson, so you've firstly introduced gas deduce, we can put the check up here. You've introduced that in the first lesson, you've given them an example of this, and we'll see this in every single scheme of work, this model being used to give us some sort of picture with which to make sense of things. What we're going to move into in the next lesson is energy, and start to look at energy in more detail, and then in the lessons after that sequence of lessons on energy, that's when we start to look at matter. So that's things like solids, liquids, gases, conduction, convection, density, pressure, all of these things. And that's what we'll begin to talk about in the next video. Thank you.